Okay, this is a question about solving systems of equations. The first one, we have to use the elimination method. So why don't we write down our equation? For elimination method, both equations should have the letters lined up. So notice how the x's are above one another and the y's are above one another. That's the first necessary thing to do elimination. So why don't we first eliminate the x's? The way we do that is by getting the numbers in front of the x's, namely the coefficients, to be the same, or to be negatives of one another. If both of these coefficients are the same, I could subtract the two equations to eliminate them. But if alternatively, if they're negatives of one another, then I would add the two equations to eliminate. For me, I prefer to add. So what I'm going to do is, I would like both of these to be the same number but negatives of one another. So how about I leave this as a 4 and I aim to make this a negative 4. And I can easily achieve that just by multiplying this second equation by multiplying it by negative 2, right? And this first equation I'm just going to leave alone. So if you are picky, you can think of it as multiplying by 1. So the first equation just stays the same because multiplying by 1 doesn't change anything. Now, for this one, I got to multiply by 2. 2 times negative 2 is negative 4, so negative 4x. But remember, you have to multiply everything by negative 2, not just the first number. So when I multiply this one by negative 2, I get negative 4y. And this times negative 2 is negative 6. And now I'm going to add these ones. What do I get? Well, the whole purpose here is when I add these two, they go away. 4x plus negative 4x is just 0x, or 0. And so I don't even really have to write anything there because it's nothing there. How about this? 7y plus negative 4y, that's 3y. And 2 plus negative 6 is negative 4. So now I can easily find y. I just divide both sides by 3. 3 over 3 is just 1y, or just y. And negative 4 over 3 can't be simplified, so there's my answer. Now I need to find x. To find x, really I could just choose one of these equations, say the first one, and replace y by negative 4/3 in there. And then I'd have an equation just in x, and I could easily find x. But just to get some more practice with elimination, why don't we use elimination again to find x? That means we would have to make the numbers in front of y the same. So that'll be our goal this time. Or the numbers in front of y to be negatives of one another. Both would be acceptable. Since I did addition on this one, why don't I try to use subtraction on this one just to show you the different way of doing it. So I would like the numbers in front of y both to be the same. In this last one, I got away with just multiplying one of them by a number, and the other one I just left alone. But on this one, I think I'm going to have to multiply by something on both. Really, I could multiply this first one by 2, because then I get a 14 here. And I could multiply this one by 7 to get a 14 there. So let's see what happens. Just remember, when you have this multiplication, you have to hit every single term by that number. So 4 times 2 there is 8x, plus 14y equals 4. This time I multiply every single thing by 7. So 14, this should be x, of course. 14x plus 14y equals 21. And now this time I'm going to subtract, right? 8 minus 14, negative 6x. 14y minus 14y is just 0, so it goes away. 4 minus 21, that's negative 17. And now what I'm going to do is isolate for x by dividing both sides by negative 6. Negative over negative there is positive, so it's 17 over 6. And there we go. So we found our two answers. Let's write them over here. So x is 17 over 6, and y is negative 4/3. Now, it does make me a little bit nervous that the answers are these ugly fractions. Sometimes teachers are nice, and they make the answers work out to be nice whole numbers to know for sure that you have the right answer. How can we check our answers? Well, this is actually not very hard because here's our system. Why don't we just put these numbers in our calculator and work them out and see if we really get 2 when we put it in the first one, and see if we really do get 3 when we put them in the second. So if I do 14 times 17 over 6 plus 7 times negative 4 over 3, and I press equals, I get 2. So that's a good sign. And if I tried in the second one as well, 2 times 17 over 6 plus 2 times negative 4 over 3, I get 3. So that gives me confidence that these ugly fractions are actually the right answers. Okay, so that completes the first one. What about the second? So this second one here, we have to use substitution rule, right? Let's move that down here so we have some more room. And give me 1 second. All right, so this is B. Substitution rule. Whenever you see a letter all by itself like this with a coefficient of 1 in front, that's a real sign that substitution rule is going to work for you. Why don't we get x by itself? That's very easy. I just need to bring the minus 2y over, and I'll have x by itself. Now you know this minus 2y, I can put it right there, or I could put it afterwards. It really doesn't matter. I think I'm going to put it in front. So it'll become positive 2y, and then I have my minus 2 there. Now that I know what x is, what I'm going to do is I'm going to recopy this equation here, okay? 3, there's my x, minus 6y equals negative 3. But I don't want to write x in there anymore. What I want to do is replace x by this quantity. I'm allowed to do that because they're equal to each other. And I obtain this. So basically all I did is I replaced, in this equation here, this x, I put this in place of it. Well, technically I put this 2y minus 2 in place of it. So let's see here. What I want to say is that notice now we have an equation that's completely in y. And that's good because we can solve for that now, right? Let's see what happens. If I multiply this 3 across, I get 6y minus 6. And, oh, look what happens here. If I get all y's on one side and all letters on the other side, I obtain this. 6y minus 6y is 0. And 6 minus 3 is 3. So look what I get. 0 equals 3. We talked a little bit about that before, right? This is false, isn't it? So that means this equation has no solutions. And that means the entire system has no solutions. So our conclusion for this one is the system has no solutions. That's possible. Just like with one equation, you can have like one answer, you can have no answers, or you can have infinitely many answers. This one turns out to have no solutions. If you think about it a bit back here, it's kind of clear that that's the case because let's say that let's say we have some numbers x and y which make the first equation true, okay? If I multiply everything here by 2, or no, let's say I multiply everything by 3, what happens if I times by 3? I would get 3x minus 6y equals negative 6, right? But this second equation says it's required that 3x minus 6y be negative 3. But that's impossible, right? If the first equation turns out to be negative 2, then the second equation has to turn out to be negative 6. There's no way it could be negative 3. So that's maybe another way to see why it's true that this particular system has no solutions. But if you, really, if you just proceed using good faith that it's going to work out fine, and then you end up with something weird like this, 0 equals 3, it's obviously false, then you're allowed to conclude that this system has no solutions. So that completes this one.